Okay, so we are live. So today we're going to discuss age word problems. Word problems in general freak people out. They freaked me out. And when I was a kid, they freaked a lot of kids out. And so the more you do them, the easier they become. You know, you start to learn how to, oh yeah, I guess that means I need to multiply this or divide this or whatever. All those things are, you know, just, it will never get easy unless you do a lot of them. That's just the way it is. Okay. And every now and then there's somebody who like has no trouble with word problems, but it's really rare. So, you know, most people have trouble with them. And so my approach is, well, with Saxon, we do whatever, you know, we do the ones that Saxon teaches. Plus, I don't believe they do the age word problems. And but my idea is to just expose you to different ones and a process that actually helps you solve them so that they're really quite simple. So let's read this. It says, Aunt Petunia is 4 times as old as Dudley. 6 years ago, the sum of their ages was 33. How old are they now? So I have no doubt that if I split you up into groups and I said solve this problem, you would solve it. You know, if nothing else, you could probably just start picking. You know, you could do a guess and check method, right? Well, let's see. One could be 1 and the other could be 4. 4 times.
Dudley is 9.
Is it?
Yeah.
I don't even know. So we'll see. Okay, that's your prediction. 36 and 9. 36 and 9. That sounds about right. That might work. So I think that is right, actually. So, and I'm starting very simple. These are simple ones. They get more complicated. So this is a simple one. We're also going to do another one that is more complicated. Okay? But I'm going to show you the process that makes it simple regardless of whether they're complicated or simple. It's a very, very simple process. You always start with a box. Okay? A box with 2 rows, usually 2 rows, and 2 columns. Okay? So this is what you do. So we're going to have 2 columns and 2 rows. And in the top left, I want you to write all this down in your notes. It's real important it's in your notes. We've got Aunt Petunia and we have Dudley, right? So we got Aunt Petunia and we have Dudley. And then there's 2 columns. These columns are really important. The first column is the now column. I just write now, but really basically what it means is their age now. You could write age now if you want. You know, I'll do that. I'll put age now for that first column. And in the second column, well actually before I do the second column, let's just figure out what goes in the first column. Aunt Petunia and Dudley. Aunt Petunia is 4 times as old as Dudley. Whose age is based on the other person's age?
Aunt Petunia.
Okay, so who's the base's age? I mean, who? Dudley. Do you guys all see that? That Dudley is sort of the foundation. You can't know Aunt Petunia's age until you know Dudley's age, right? Because it says Aunt Petunia is 4 times as old as Dudley, right? So let's make Dudley X. Whatever is the base, that's going to be X, okay? Now, I'm going to come over here, and Dudley's age right now is what?
X.
Right? Now, what is Aunt Petunia's age right now?
X plus 6.
4x. 4x.
What do you think? I'm hearing X plus 6 and 4X.
4x plus 6.
Everybody agrees? It says Aunt Petunia is 4 times as old as Dudley, 4X. I agree with you. All right. Now, this is where people screw up. This is where everybody in this room will probably make this mistake at least once. And so I'll tell you now so that you are aware of it when you start making it. This is what most people do. They say, 6 years ago, the sum of their ages was 33. So they try to get 33 in here, and 6, and I don't know,
I think it's a minus.
39.
they might divide by 2 because it's the sum, and then they think, well, maybe I need the average. And then, I don't know, don't do that, right? That is not the thing to do. Don't try to squeeze Don't try to squeeze every other bit of information in this one little box. What you do is, I'm going to even use a different color pencil, marker. When it says 6 years ago, stop! Stop! Okay? When it says 6 years ago, you stop. You do not go past 6 years ago. You stop. Okay? And when you stop, that's what we got to put into the column here. And we have to fill out this entire box. Before you read any further, do not read any further until this entire box is filled out. What would this column be? If this column was age now, what do you think this would be?
Oh, 6 years ago.
6 years ago. Okay. Now, I could write 6 years ago, but how would you write that in math, 6 years ago? Minus 6. Right, exactly. So I'm going to do minus 6. I'm going to actually I'll do this in red. Minus 6. Now what people want to do is they want to start reading. They want to read the rest. Don't go there. You got to finish the thing yet. You have everything you need to know. If Aunt Petunia's age now is 4x, what was her age 6 years ago?
4x minus 6.
4x minus 6. 4x minus 6. And what was Dudley's age 6 years ago?
Minus 6.
X minus 6. All right, so now that you've filled this entire box in, it's totally legal to keep going and to read further. So 6 years ago, the sum of their ages was 33. So how would I write that in an equation? Sal is so effervescent and excited today. Go ahead, Sal.
4x minus 6 plus x minus 6 equals 33.
So that's the sum, right?
But you do
The sum of their ages. Now the question is, why did I choose this column?
Because it's asking about 6 years ago.
Right, it says 6 years ago, the sum. So that means I'm going to use this second column. And in all of these problems, that's what you're going to use. You're going to use the information in the second column. Okay? So the sum of their ages, the sum of 4x minus 6 plus x minus 6 is equal to 33. Oh yeah, sorry about that. Okay, so now we keep going. So what do we have? We have 4x plus 1x is how many x's? 5x.
12
And then minus 12 equals 33. Now what do I do?
plus 12.
Plus 12, right? That way those will cross out. Plus 12. Draw my line. Got 5x
45.
is equal to 45. Divide by 5.
And x equals 9.
So x is equal to 9. I'm done!
No, you're not.
Oh, shoot. Right. This is a word problem. Right? Word problem. So I have to answer this in words, but I got to figure everything out first. So do I have to subtract 6 from, add 6 to all this in order to find now's
No,
age?
you multiply it by 4. Multiply it by 4 for Aunt Petunia, and you keep it the same for Dad. No, wait. That's
So you're right. So this is another place people tend to get confused, is they think, well,
Not 6 years ago, so you need to add 6.
yeah, see, that's where a lot of people get confused. Because they think, well, they solved, first, they were using information for 6 years ago. And so they think, oh, well, this is 6 years ago. This is how old they were 6 years ago. Actually, no. Let's look at this. Look at your box now. Where does it say x? We just solved for x. And x is Dudley's age now. Right? And so the reason we can do this and use it with 6 years ago is because this is using x, but we're subtracting the 6 here. You see what I'm saying? And so it's still based on x, which is their age now. So that's what x is. So x is Dudley's age. So we can say now, Dudley
Is 9.
Dudley is 9 years old, and Aunt Petunia is
36.
36
See, I was
years
right.
old. Wow, you did it, Sal. I'm glad I taught you. I'm kidding. Well, I am glad I taught you, but it's like, I'm glad you got it very quickly. Very good. Does that make sense?
Yes.
They're really fun to do. I think they're really fun to do. Because, you have this process and it's like, oh, I just draw my box and you start putting the information in the box and you know, it's kind of cool. So, so now I'm going to actually show you how to do one that's a little more complicated.
Yay!
Okay? It's not that much more complicated. It's just that it's, what? Sorry?
We get to have like 6 ages.
Say it one more time.
We get to have like 6 ages.
No, it's still, most of these still are going to have just 2 people. You can do more, but for these I'm keeping it simple for now.
Okay.
And what else was I going to say? It's just that, like this, the sum of their ages was 33. That's pretty easy, right? You just take this plus this equals 33. Sometimes what they say in that second sentence is not quite as simple. Can I erase all this? Are you done, Sakara? Can I erase? Okay. So I'm going to write the next one. And if you guys can write while I write, that would be great, so that we can move right into solving it when I'm done. Since we're on the video here. Okay, here we go. Matt is 4 years older than Todd. 4 years older than Todd.
Wait, is this true?
Are you serious?
I don't know. I lie in all of these, just so you guys know. So, so Nate, this was Nate's lie or truth or whatever. In 3 years, twice Matt's age will be 8 more than twice Todd's age. 8 more than twice Todd's age.
So it's just like twice of both of their ages. Kind of a given?
Find their ages. All right. So Matt is 4 years older than Todd. In 3 years, twice Matt's age will be 8 more than twice Todd's age. Find their ages. So I'm going to do that great little box. It works. It'll be so easy once you do that. So we've got our little box, 2 columns and 2 rows. I know this is going to be my now column. I always make my first column my now column. Almost always. Sometimes I might sometimes I do 3 columns depending, I mean, if it's a really, really complicated one. Then, but that's, you know, where you have an age now, you have an age 2 years ago, and you have an age next year, right? Suddenly then you have to have a column for every age, for every year, you know what I mean? But in this, these are all just 2 year, you know, now and some other time other than now. So we got Matt, and we've got Todd, right? Okay, what do I put in what? It says Matt is 4 years older than Todd. Which will be X, Matt or Todd?
Todd.
Does everybody agree with me? Agree with that? It's going to be Todd. Everything's based. Matt's age is based on Todd. So I'm going to put an X above Todd's right now, so I don't forget. All right. So I'm going to put now Todd's age is X. What's Matt's age?
X.
4x.
Again.
All right. I'm hearing 2 things. I'm hearing 4X.
Oh no, 4.
And I'm hearing X plus 4. Which is it?
X
plus 4.
X plus 4.
Yes.
4 years older than. It doesn't say 4 times as
That's
old.
old.
4 years older, so it's X plus 4.
That would be cool.
Okay, now what do I put for the column heading in my second column? It says in 3 years. Mathematically, how would I write that? Plus 3. So I'm going to write up here plus 3. And so this is what you have to understand. To fill in this column, that's all you need. You don't, by the way, I didn't put that big red line there, but you don't read past that in 3 years until this is all filled out. But this is where people kind of screw up. Sometimes, and they get it now, you'll get it now, but then when you do this 2 or 3 weeks from now, you're going to think, oh, shoot, how do I figure out what this is? Well, that's why you put the plus 3 here, because all it means is you take whatever is here and you plus 3 to
So
get
it's
this.
X plus 4 plus 3.
Right, which is?
X plus 7.
You got it. So this is going to be x plus 7. So x plus 4 plus 3, 4 plus 3 is 7, x plus 7. What would this be? X plus 3. Okay. So now that we have our chart completely filled out, we are going to be using this column because that's what the next sentence is. It says in 3 years, twice Matt's age will be 8 more than twice Todd's age. So let's write that. How would I write that? Twice Matt's age. How would I do that?
2x in parentheses times 2. And then,
So is the parentheses really important? Can't I just do this?
yeah.
Why can't I do that?
Because you need to multiply x plus 7 by 2.
Yeah, if I just did this, all I'd have to do is
Then it's
multiply the
2x
x times 2. And then I wouldn't have to multiply it times 7, right? But
You could do 2x.
his age is x plus 7, so you got to multiply the 2 times everything, not only just the x, but also the 7.
And plus.
Right? So, okay. So twice Matt's age. We just dealt with this. Twice Matt's age. Will be. Will be. Will be. What's that?
Equals.
I hear an equals. Do you guys agree? How many people agree?
Yeah.
Yeah, I think so.
Yes. Remember the verb to be, is, was, will be. Doesn't matter what tense it is. Right? Is, was, will be. Those are all the verb to be. So anytime you see the verb to be, it's an equals, right? So equals. Will be. 8 more than. 8 more than. What do I do with 8 more than?
Plus 8.
Where do I put the plus 8?
At the far
Right.
right.
I'm going to put over here. Put plus 8.
Plus 8.
Okay, now it says 8 more than. Okay, I dealt with that. Twice Todd's age. What would I put for that?
2x plus 3. 2 parentheses x plus 3.
Got it. 2 parentheses x plus 3. You guys rock. Okay, let me just see. Then twice Todd's age. We did it. Okay, there's our equation, our mathematical equation. So we are going to use the distribute
So
property.
then it ends up being
And this and this.
the same thing.
So we have 2x plus 14 is equal to 2x
plus 14.
plus,
14.
6 plus 8. Okay, so we've got 2x plus 14 is equal to 2x plus 14. I think that's fairly accurate.
Yeah,
When you-
that's what I didn't like.
Clever, Nate. Nate, did you solve
Zero.
Nate, did you solve this after you wrote it?
I did it the opposite.
I think this will be 0
Ah.
equals 0.
Okay.
Or 14 equals 0.
Okay, you guys are gonna. This is a great. So you have learned how to solve these, right?
Yes.
Now, unfortunately, we have an interesting dilemma here, because think about it. How many people would agree with me that 2x plus 14 equals 2x plus 14?
Yeah. Totally just.
Did you guys figure that out in your head?
No.
That they're identical? Okay, so watch this. If let's say I subtracted 14, because I want to get rid of this. I want to say just x. I'm going to subtract 14. Look what happens. I've got 2x is equal to 2x minus 14. That's interesting. So now what am I going to do? I'm going to subtract 2x.
No, it's not minus 14. Plus 14.
I was going to say, that seemed clear. So those both cross out, right? So now I've got 2x equals 2x. Well, I want the x's on the same side. So I'm going to subtract 2x from both sides. Oh, this is really cool. 0 equals 0. Oh, that's interesting.
So they're both 0. No, it's 0. It's 4 and Todd is 0.
So actually, this is really good. So what does this mean? Come on, use logic now. What does this mean?
Well, Todd is 0 then it'd be 4, and then in 3 years, twice of that would be twice 4. In 3 years, twice 7 would be 14, and currently Todd is not 8, 0.
I do it right? I did it right, right?
Yes.
There are an infinite number of solutions.
Right. So look, because you got to this point where you got 2x plus 14 equals 2x plus 14, it means x could be 1, x could be 0, x could be 2, x could be 2 times 17 plus 14 is equal to 2 times 17 plus 14. So we don't know. There's no way to solve it, right?
But let's
With
say
the,
it was
with
1.
the information we were given. I don't know where we got this problem, but it's definitely...
Let's say it was 1. If he's 4 years older than 1.
So then Matt
One
is
will
4.
be 1. The other guy will be 5. In 3 years he'll be 8, and the other guy will be 4.
Right.
8
So
times
you need
2
to spend the next
16.
infinite number of years
That works.
writing down the answer to this problem. If Todd is 0,
That is 0.
Matt is 4. If Todd is 1, Matt is 5. Yes.
Stupid.
Don't you put all the X's on one side?
I did.
Until you reach like 100.
I did. I subtracted the 2 x's. I subtracted 2 x's,
And that equals
and I
0.
got 0. Because I've got the same number of x's on both sides. So, when this happens, the place that this happens is when you have the same number of x's on both sides of the equal sign, right? Because when you try to get all the x's to one side, then suddenly they disappear. And if they disappear, sometimes you'll have a truth and sometimes you'll have a false statement. In this case, everybody listen for a second. In this case, we had a true statement. 2x plus 14 is equal to 2x plus 14. Sometimes you'll get something like this. You'll have, 5x plus 2 is equal to 5x minus 17. And you think, well, at first you think, oh, no problem. So I got to get all the x's on the same side. And so you subtract 5x from both sides. And you get 2 is equal to negative 17.
The answer to this equation
And you
is
say, well, wait a minute, I used math. Why is this not working? And when this is what you get, when you get, is this true? No. So when you get a non-truth, right, it means there are no solutions. When you get a truth, would you agree with me that this is a truth? 2x equals 2x. When you get a truth,
infinite number.
yeah, but you can't go any further, really. You get 0 equals 0 or whatever. Then it means there's an infinite number of solutions. You could make x anything, and you'd still get an answer, right? So that's helpful to know because I don't give that too many of those, but it's like you will get stuff like that on the MWEA
Calculus.
tests and the SAT tests in high school, where they'll give you something on purpose that has no solution, and they want to see if you know that it has no solution or that it has infinite number of solutions. So this, I would have to say,
Matt is any age but 0 plus 4.
there are
Matt is
infinite.
4. Todd, Matt is any age above 4. Above 5.
4 and
4.
4 and over. So you could be 4.
No, because that would make the other guy 0. And
Yeah, but
wait, because 0, okay, so 0 plus 4 would be 4. So then he would be 4, the other guy would be 0. In
Yeah.
3 years he would be 7. Twice 7 is 14. Twice 0 is 0. 8 more than 0 is 8. 14 does not equal 8. So it has to be anything, Matt's age is anything above 5.
It would be easiest to ask Todd in this case, right? It definitely would be the easiest way. So that is how they work. What?
0 is equal to 0.
Yes, which is true. And since it's true, there are infinite number of solutions. If I put a 10 in here and a 10 in here, I have 20 equals 20. If I put a million in here and a million in here, I get 2 million equals 2 million. So it's always true. So x could be anything given the information we were given. In truth, we were not given enough information in this problem to actually solve for their actual ages now.
Matt is any age above 5 and Todd is Matt's age minus 4.
I get that.
Thank you. That is very helpful. That was good. Okay, so I'm going to stop this thing.